Alright, I want to look at how to find the asymptotes of a hyperbola. Um, Hello, by the way, hope you're doing well today. The asymptotes are these lines that aren't actually part of the graph of a hyperbola, but they're these lines that the curves of the hyperbola approach but never actually touch. And if you graph the asymptotes, it makes it a lot easier to actually more accurately draw the hyperbola, right? Because you can um, start with a vertex, just draw the curve approaching, approaching, approaching the asymptote, approaching, 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 approaching. Okay, so how do you find where these lines are? Well, it's actually fairly straightforward to find the equations for each of these two lines, like this. So for a hyperbola that opens to the left and to the right, like this one pictured above, um, the standard form equation would be x minus h squared over a squared minus y minus k squared over b squared equals 1, where h and k represents the coordinates of the center. A represents the distance from the center to the vertex, A, A. B is the height of what's called the fundamental box, and it's related to A and C. Um, and where C is the distance from the center to the focus. All right, so you can just take the equation in standard form and then figure out the two equations for the two asymptotes like this. So the equations are for a hyperbola that opens to the left or to the right. If it opens up and down, you just flip this part. Um, so y equals plus or minus, hence you're going to get two equations, plus or minus b over a times x minus h plus k. All right, so let's practice. Here we've got an equation for a hyperbola. Let's practice um, writing the equations for the two asymptotes. Okay, so uh, first of all, a is by definition greater than b. So first look at these bottom numbers. The larger one will be a. Uh, so if a is under the stuff with x, then it's a hyperbola that opens to the left and to the right. Um, if if this y stuff is over the larger number, then it opens up and down. Okay, so we know because this number is larger than this one, um, that this is a, this is b. So hence it's a hyperbola that follows this pattern. The x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, so what we need is a and b. What we've got is a squared and b squared. Um, so let's find what a and b are. So if a squared is 100, then a is 10. And if b squared is 25, then b itself is 5. Yes? Okay. Um, x minus h we've already got here. So this part of it is x minus 2. And k is 3. So the equation says y minus k squared. So y minus 3 squared. So 3 is k. Okay, so here's our equations for the asymptotes. Y equals plus or minus b over a. So let's start with plus. B over a, so 5 over 10 times x minus h, so x minus 2, plus k. K is 3. And then our other asymptote is y equals negative 5 tenths x minus h plus k. And maybe to graph these, we want to simplify. So 5 tenths is 1 half. So y equals 1 half x minus 2 plus 3, y equals negative 1/2 x minus 2 plus 3. And maybe because you like things in slope-intercept form, you want to distribute that 1/2. So the first equation would be y equals 1/2 x minus 1, 1/2 times negative 2 minus 1 plus 3. And then the other one would be y equals negative 1/2 x plus 1 plus 3. So y equals 1/2 x plus 2 would be the first one. I kind of feel like I'm writing this too many times. And y equals negative 1/2 x plus 4. Those would be the two equations for our asymptotes. Then, just graph them. Y-intercept is 2. Slope is 1/2. Plot another point. Draw the line. Y-intercept is 4. Slope is negative 1/2. And then, plot another point. Connect those. Draw those lines. So I'll let you handle it from here. Those are standard linear equations in the slope-intercept form. So then you can draw the two asymptotes, and then when you figure where the vertices are, then it's pretty easy to graph from there. So they approach the asymptotes, but don't touch them. All right, good luck.